The question is, a hollow iron ball of volume 200 centimeter cube weighs 90 gram. The ball floats on the water surface. Now calculate the effective density of the steel ball, the fraction of volume of the iron ball which is above the water surface, and the apparent weight of the ball while floating. Given that density of water is 1 gram per centimeter cube. Now, for the effective density of steel ball, we know that density is equals to mass upon volume. We have been given the mass as 90 gram and volume as 200 centimeter cube. So the density would be 90 divided by 200 gram per centimeter cube, that is 0.45 gram per centimeter cube. Second is the fraction of volume of iron ball above the water surface. Since the ball is floating, which means that some part of the ball is above the water surface and some is below the water surface. Now, since it is floating, the volume of water displaced equals the weight of the ball. So, the displaced volume can be found out by mass of the ball divided by density of water, which comes out to be 90 centimeter cube. Okay. Now, from this we can easily find out the fraction of submerged volume. Okay. So, the submerged fraction would be the displaced volume divided by total volume. So, the displaced volume is 90 centimeter cube and the total volume is 200 centimeter cube. Okay. So, it comes out to be 0.45. Okay. So, this is the fraction of the submerged part. Now, the fraction of volume above the water can easily be found out by 1 minus the submerged fraction. Okay, 1 minus the submerged fraction, which was 0.45, which comes out to be 0.55. Third is the apparent weight of the ball while floating. So, the apparent weight of an object while floating is effectively zero because the bind force, that is Fb, equals the weight of the object, that is mg. Now, bind force is equal to the weight of the water displaced, that is equal to the volume of the water displaced into density of water into gravitational acceleration g. That is 90 centimeter cube multiplied by density of water, that is 1 gram per centimeter cube into gravitational acceleration g. Okay. Now the apparent weight W dash will be equal to the actual weight minus bind force. So the actual weight is 90 gram into gravitational acceleration g minus 90 gram into g, that comes out to be 0. Therefore, I can say that the apparent weight of the ball while floating is 0. Okay, I hope it is clear to you. Thank you.